Good morning, everyone. So, welcome to class number 1, teaching remotely. Something new. So, what we're first going to be doing with remote teaching is we're going to be doing chapter 10. Now, I hope that before starting chapter 10, you already took the chapter 9 quiz on My Math Lab. Remember that you had 3 attempts, and I was going to take the highest grade. And that if you did qualify for the extra 5% for the practice test, I am going to add that to your quiz. So now that that is done, we should be on chapter 10. So section 10.1, we're going to be getting into a chapter 10 patterns and sequences and series and probability and all these things. So definitely much better than ellipses and hyperbolas and parabolas. So that's something that we definitely have to look forward to. And I would say this is definitely something that there are plenty of videos other than mine online you can always look up. And that this is something that there's lots of practice. And if you ever want any more extra practice, please let me know. So our learning intention is that we will review sequences and summation notation so that we can gain a foundational knowledge necessary for this chapter. Now, the things we're going to be able to say we can do are I can successfully write terms of a sequence from the general form. I can successfully write terms of a sequence using the recursion formula. I can confidently use factorial notation, that's that little exclamation point you guys have probably seen before. And I am able to use summation notation in order to solve problems and also write patterns in summation notation. Now, sequences. An infinite sequence is a function whose domain is a set of positive integers. So, basically my natural numbers. Okay, remember natural numbers are counting numbers. 1, 2, 3, 4, so on and so forth. So no decimals, no negatives, no zero. And the function whose domain is set of positive integers, the function values or terms of the sequence are represented by these. So here are the terms within this. When I say A and then that's subscript, so it's below A of 1, that means the first term, the first number in this pattern. A of 4 would be the fourth number in this pattern, and so on and so forth. We use A of n to represent the actual pattern or the sequence. Okay, so instead of what we're used to with f of x, we're not doing that anymore. It's going to be A of n. Now, example 1, writing terms of sequence from the general term. So something like this, I'm going to ask you to write the first 4 terms of the sequence whose nth term or general term, so the nth term is also the general term, is given. So this first one, 3n plus 4. We know this from functions as being a linear function, so it's going to be one of those like consistent changes. So the first term, when I do A of 1, basically your n is what you're going to plug into the formula. So 3 times 1 plus 4. So 3 times 1 is 3, plus 4 is 7. So that's the first term. Now we got to find the second, the third, and the fourth. So the second one will be 3 times 2 plus 4. So 6 plus 4, we get 10. The third term is 3 times 3 plus 4. So 9 plus 4 equals 13. And then 3 times 4 plus 4. So 12 plus 4 is 16. So my first 4 terms are 7, 10, 13, and 16. If you just look at the numbers, you see, oh, the pattern is plus 3, plus 3, plus 3. That's why it's times by 3. Now, the plus 4, that would have been so the 4 would have been the 0 term, but we don't have a 0 term in this case. It just kind of helps us figure out the pattern. For this next one, so first 4 terms, right? So A of 1, remember, it's just following PEMDAS. So it's -1 to the n, which is 1 power. over 3 to the first minus 1. Negative 1 to the first is negative 1. 3 to the first is 3 minus 1. 3 minus 1 is 2. So we get negative 1/2. A of 2, negative 1 squared over 3 squared minus 1. So it's positive 1 over 9 minus 1, which is 1/8. A of 3 is negative 1 to the third over 3 cubed minus 1. So it's negative 1 over 27 minus 1, which is negative 1 over 26. And then last, negative 1 to the fourth over 3 to the fourth minus 1. So it's positive 1 over 81 minus 1, which is 1 over 80. So that is how we find our first 4 terms of our sequence. What I'd like you to do, pause the video and do checkpoint 1 on your own. Gotta plug in my charger. Okay, so checkpoint 1. Want to find the first 4 terms from the general term a of n. So a of 1 is 2 times 1 plus 5. 2 times 1 is 2, plus 5 is 7. A of 2 is 2 times 2 plus 5, which is 4 plus 5, 9. 2 times 3 plus 5. 2 times 3 is 6, plus 5 is 11. And 2 times 4 plus 5. So 2 times 4 is 8, plus 5 is 13. With B, a of 1 is negative 1 to the first time over 2 to the first plus 1. So negative 1 to the first is negative 1. 2 to the first is 2, plus 1 is 3. A of 2 is negative 1 squared over 2 squared plus 1. So it's positive 1 over 4 plus 1, which is 5. A of 3, negative 1 to the third over 2 to the third plus 1 is negative 1 over 8 plus 1, which is 9. And then a to the fourth, negative 1 to the fourth over 2 to the fourth plus 1. So it's positive 1 over 16 plus 1, which is 17. So that is how we find our terms using the general formula. Now the general formula, okay, so general formula, or the general term, is where you plug n into find term. Okay, so you could plug in, so if I want the 10th term, I could plug in 10 into the pattern or the function, and I will get my 10th term in the pattern. Now, something to keep in mind, remember when it's talking about sequences, they are similar to functions, but they are different. Okay? The one on the left, this graph, is f of x. This is as if I had the function 1 divided by x. Okay? Technically, x could be whatever it wants, right? It just all depends on what the y is when we have a function. However, when we're talking about a sequence, okay, technically, your domain, your n must be a natural number. 1, 2, 3, okay? So on and so forth, counting numbers. We can't have decimals. That's why, if you notice, these points here, usually we would connect them, but because we only connect them if we could have decimals. So we're not going to connect these. Okay, but our range, technically we could get any answer we want. All right, so it's going to vary from problem to problem, but really, for any sequence, we can have any number for our range. It could be anything it wants. It's just our domain has to be natural numbers. So if you do see a graph, maybe in your homework, when it's saying, oh, the A term and the B term, do something with them to add, and you're only given graphs, the graphs just give you your answers. So in this case, A of 1 is 1. In this case, A of 2 is a half. A of 3 is a third, and so on and so forth. That's how you would read it. Now, recursion formulas, okay? So we have the general term, that's just our basic pattern sequence. But a recursion formula is when, basically, think about recursion reoccurring. We are always going to be using the previous number within the pattern to create the formula, okay? So when working with recursive formulas, you will always be given a term, all right? So find the first 4 terms of the sequence in which A of 1 is 5, so I gave you the first term. And A of n is A of n, 3 times A of n minus 1 plus 2, where n is greater than or equal to 2. So see how you see a term within the pattern, right? So you need the previous term, that's why n minus 1, in order to find the next term. So that's why you have to be given a term to start with, because if you don't have a term given, then you don't know where you have to start from. So basically, my first term, because I want the first 4 terms, it was already given to me, 5. The second term, according to this formula, would be 3 times A of 2 minus 1 plus 2. So that's 3 times A of 1 plus 2. So they basically want me to take the first term, which is 5, times it by 3, and then add 2. So it's 15 plus 2, 17. Okay, recursion, always using a term to find your next one. So 3 times A of 3 minus 1 plus 2. So 3 times A of 2, because that's 3 minus 1, plus 2. 3 times A of 2 was 17, plus 2. 3 times 17 is 51, plus 2, we get 53. Now last, A of 4 is 3 times A of 4 minus 1, plus 2. So 3 times A of 3 plus 2. So it's 3 times 53 plus 2. Now 3 times 53 is 159 plus 2. I get 161. Now the thing you have to be careful with this formula is that if you mess up, let's say I messed up A of 2, that's going to mess up me finding A of 3 and A of 4. So you have to be careful with this. Also, another thing, if you look this up online, you may see that they do A of n plus 1 equals 3 times A of n plus 2. It is similar. It is kind of the same thing in a way, all right? But just keep that in mind, all right? It's still the same thing. Just the n plus 1 means my next term. I'm going to use the current term I have to find the next term. So pause the video, try out checkpoint 2. Okay, so I want to find the first 4 terms of the sequence. A of 1 is 3, and A of n is A of 2 times A of n minus 1 plus 5. So my first term is 3. My second term is going to be 2 times A of 2 minus 1 is 1 plus 5. So 2 times 3 plus 5, 6 plus 5 is 11. A of 3, they want me to do 2 times A of 2 plus 5. So it's 2 times 11 plus 5. 22 plus 5 is 27. And then A of 4 is 2 times A of 3 plus 5. So 2 times 27 plus 5. 2 times 27 is 54 plus 5 is 59. So those are 2 different types of ways we could see a sequence. We could see it as a general term, where we just plug in n. And we could also see it as a recursion formula, where we're actually using a term. All right, once we have A of within it, then it's a recursion formula. Now, factorials. You have seen factorials before, okay? It's kind of the exclamation point operation within math. Now, factorial notation, if you want to do this in your calculator, if you press Here, let me write this a little bit up here. If you press math, the math button, and then you scroll on over till you're highlighting PRB for probability, you will see the fourth option is the factorial. Okay? I believe it's option number 4. It might be option number 3 or something like that. But that's it. All right, once you see the exclamation point. Now, basically all the exclamation point is saying, so like 3 factorial. That is 3 times 2 times 1, which is 6. 6 factorial. 6 times 5 times 4 times 3 times 2 times 1. 720. So that is what the factorial is. You're basically taking that number and multiplying it to every other counting number all the way to 1. All right. Now, because 0 is kind of one of those special cases, 0 factorial is just going to be 1. All right. Now, these are in your notes. I have all the way up to 20 factorial. Do you need to memorize this? No, your calculator can do this for you, so that's totally fine. So now, how would I you may see this operation symbol within a sequence or a pattern, so it's just something to keep in mind. So, for example, 3. Write the first 4 terms of the sequence whose nth term is, so this would be the general term. Okay, this is not recursion because you don't see an a of within the formula. So, a of 1 equals 2 to the first over 1 minus 1 factorial. So it's 2 over 0 factorial, which is 1. So 2 divided by 1 is 2. Second term, 2 squared over 2 minus 1 factorial. 2 squared is 4. 2 minus 1 is 1 factorial. 1 factorial is 1. So 4 divided by 1 is 4. The third term, 2 to the third divided by 3 minus 1 factorial. 2 to the third is 8. 3 minus 1 is 2 factorial. 2 factorial is 2 times 1, which is 2. So 8 divided by 2 is 4. And the fourth term, 2 to the fourth over 4 minus 1 factorial. So 2 to the fourth is 16. 4 minus 1 is 3 factorial, which is 3 factorial like we said before. 3 times 2 times 1 is going to be 6. But remember, we should always simplify, all right, and leave it as a simple fraction. So 16 over 6, they both go into 2, so it's really 8 over 3. So, again, we're just finding the pattern. So what I'd like you to do is pause the video and tell me the first 4 terms in checkpoint 3. All right, so first term, all right, a of 1 is 20 divided by 1 plus 1 factorial. 20 divided by 2 factorial, which is 2, is 10. Second term, 20 over 2 plus 1 factorial is 20 divided by 3 factorial, which is 6. So 20 divided by 6 is 10 over 3. The third term, 20 divided by 3 plus 1 factorial is 20 divided by 4 factorial, which that is going to be 24. And 20 over 24 is the same as 5 over 6. Now last is 20 divided by 4 plus 1 factorial. So it's 20 over 5 factorial, which if you look on the side or just do it in your calculator, is 120. And 20 over 120 is the same as 1/6. So we have our terms there. Now, something that we want to be able to do, okay, in order to think of, remember what factorials are, all right? They mean that number times all the consecutive numbers below it until you get to 1. So you can use that concept to kind of simplify without having to shove all this crazy information into your calculator. So, if I want you to evaluate these, okay, I want you to always think about how can I rewrite the largest number up top to be the same as the largest number on bottom, okay? So think about 10 factorial, right? It is the same as 10 times 9 times 8 times 7 times 6 all the way to times 1, right? Now, the 2 factorial, then the 8 factorial is 8 times 7 times 6 times 5 times all the way to times 1, right? So if you think about it, all of this is the same, right? So I can actually rewrite that fraction as 10 times 9 times 8 factorial, right? I always write the top one as whatever it is, and then once I get to the matching number on bottom, once I get to, so 8, I just put the factorial, because I know it's going to be everything all the way down the same as the other. So 2 factorial times 8 factorial. So now from here, I could just simplify. The 8 factorials cancel out, and I'm left with 10 times 9, which is 90, over 2 factorial, which is 2. And then I get 45. Now, I bet you're looking at B and you're like, oh my goodness, how am I supposed to do this? Remember, think about it. This is kind of like theory-wise, okay? Think we have n plus 1 and n. What is different from these numbers? The only difference between them is 1 above, right? So I could still rewrite this the same way. This I could think of as n plus 1 times 1 less than that. It's just n. And n minus 1 times n minus 2, and so on and so forth, right? Well, technically, I have an n factorial down bottom, right? So really, I could just go to this n and then put factorial, and it would be the same thing. So I'm going to rewrite this as n plus 1 times n factorial, all over n factorial. I can now cancel this out. So my answer here is just n plus 1. Now, I do want to show you another problem, okay, that's not on here, but I'd like to just show it to you. What if I gave you, let's say in the homework, I gave you n factorial over n minus 2 factorial. Technically, which number is bigger out of these two? N factorial is, because the other one is 2 less. So I would write the bigger one, n, as n times what's below it, n minus 1. Then 1 below that is n minus 2. Oh, it matches now, so just put the factorial there. All over n minus 2 factorial. I can now cancel that out, and I'm left with n times n minus 1, which I can simplify by just distributing the n, and I get n squared minus n. If something like that happens where you're left with some things, I want you to multiply them. All right, you may see that in the homework. Okay, I want you to pause the video and do checkpoint 4. Okay, so for A, which one's bigger out of all these? 14. The next biggest one on bottom is 12, so I'm going to rewrite 14 as 14 times 13 times 12 factorial, all over 2 factorial times 12 factorial. Cancel out the common factorials. 14 times 13 is 182. 2 factorial is 2, so I get 91. Now over here, n factorial and then n minus 1 factorial. The biggest one is the top, so I'm going to write that as n times 1 less than that is n minus 1, which now matches factorial, all over n minus 1 factorial. Cancel out the common factorials, and I'm left with n as my answer. If you do have any questions about these, I understand they can be a little tricky. Just reach out to me. Now, summation notation, okay? You have probably seen this before, but it's been a while. Just know that this symbol right here, okay, is the Greek capital of sigma. All right, capital letter sigma in Greek, and basically is S for sum. All right, now you're always going to be given a lower limit, and I'm going to have an upper limit, and I'm going to plug everything in. All right, basically I'm going to plug in my lower limit and then every number leading up until my upper limit. Okay, so basically I'm trying to find all these terms, and then I'm going to add them all up, hence summation, sum. So let's try this first one out, okay? So I have A. Let me change the color a bit. So for A, I want to find the sum. All right, I know that's going to be a weird, think of it as like a sideways M that might help you in terms of drawing it out. So I want my lower limit, so I to be 1, and then the largest I I'm going to plug in is 6. And basically I'm going to plug in every number from 1 all the way up to 6, so 1, 2, 3, 4, 5, 6, into this little function here, I squared plus 1. Then I'm going to take all my answers from that, and I'm going to add it all up. So I'm going to start with an I of 1. So I'm going to do 1 squared plus 1. That would be the first, right? Now, the next one is 2. 2 squared plus 1. Okay, these numbers I'm plugging in for I, because it says I equals, right? Now I'm going to do it for 3. And I'm going to keep doing this same exact thing. I'm going to square and then add 1. All the way up until I hit 6. So now from here, it's just some PEMDAS, okay? I'm just going to find all my little terms. So 1 squared is 1, plus 1 is 2. 2 squared is 4, plus 1 is 5. 9 plus 1 is 10. 16 plus 1 is 17. 25 plus 1 is 26. 36 plus 1 is 37. So basically, if I gave you this, you could kind of try and make the connection that it's all my perfect squares, just plus 1. So now I'm going to do all this math. So 2 plus 5 is 7, plus 10 is 17, plus 17 is 34, plus 26 is 60, yep, plus 37, we get 97. Nope, hold on. 17 plus 17 is 34, 44, 54, 60, yep, 97. All right. Now B, I got to do the same thing, just my lower limit now is 4. My upper limit is 7, so I'm going to plug in 4, 5, 6, 7. And then I'm going to do negative 2 to that number power, then minus 5. So for B, 7, and now it's K. It really doesn't matter what the letter is. It's usually I or K or something like that. So I'm going to be doing negative 2 to the K minus 5. So negative 2 to the 4th minus 5 plus. So I'm plugging in each number. And then I'm moving on to the next one. And I'm going to add all these up. And now negative 2 to the 7th minus 5. So now I'm going to do all of this. So I get negative 2 to the 4th is 16, minus 5 is 11. Negative 2 to the 5th is negative 32, minus 5 is negative 37. Plus, negative 2 to the 6th is 64, minus 5 is 59. Plus, negative 2 to the 7th is negative 128, minus 5 is negative 133. So remember with your plus negative, it's really minus. So I'm doing 11 minus 37 plus 59 minus 133. And what I will get, well, that's 97. I'm going to get negative 100. Now the last one, C. All right, could look a little tricky, but we have 5, I equals 1, and then we just have the number 3, right? Now, if you notice, there's no I to plug in these 1, 2, 3, 4, 5, right? However, we still want to use an I of 1 and I of 2. Think about this as like it is constantly 3. No matter what your I is, your answer is going to be 3. So for an I of 1, I get 3. Now, an I of 2, I still get 3 because there's nowhere for me to plug anything in, right? An I of 3 is 3. An I of 4 is 3. And an I of 5, my last one, is 3, right? So it's 3 plus 3 plus 3 plus 3 plus 3. So I get 15. Okay? Those constant ones, it's just constantly that because there's nowhere for you to plug the I in. I want you to pause, try out these 3 on your own, and we should be good. All right. So I have for A, we should get the answer of 182. For B, we should get an answer of 47. And for C, we should get an answer of 20. I will have it within the OneNote, all these notes there, and I will have all the work for that. But I just wanted to give you the answer instead of killing time and doing all that. All right. Now, last on our list is going to be I'm going to give you a pattern, and you have to figure out how could I write it as a summation with that whole sigma. So we're basically going to try and figure out what is the pattern here. All right. So if I look here, 1, 2, 3, all the way up to 7, right? I'm using every single consecutive number, and I am cubing it, right? So I'm going to be plugging in some number, and then raising it to the third power. That is the pattern. Now, my lowest number that I would plug in would have to give me this, my first term. So it would have to be 1. Now, my upper limit is going to have to be 7, because it's 7 to the third. So that's all we're doing here. You're just figuring out what the pattern is. Now, this one might be a little tricky. You might think, oh, it's harder to figure out. However, if I ever give you this with the whole n, you have your pattern, okay? So this should be the pattern, all right? Just make that n your upper limit, all right? So I'm going to do the sum, and I'm going to put n up top. And my formula is going to be 1 over 3 to the, you could do I or K. I'm going to do K this time, minus 1. Okay, that's the pattern. Now, I basically have to figure out, my first term is 1, right? So I need to figure out how can I get 1 over 3 to the K minus 1 to equal 1? Well, in order for this to equal 1, I need 1 to be divided by 1, right? So this has to equal 1. Now, the only way for a number to any power to equal 1, it's going to have to be that to the 0 power, right? Anything to the 0 power is 1. So, my k minus 1 has to equal 0. So that means my k is going to be 1. So that's my lower limit. Okay, you need to be able to figure out what that lower limit is. I already give you the upper when the patterns are in like this, and the pattern itself. You just have to kind of work backwards to figure out what your lower limit is. Pause the video, try out checkpoint 6, and then we should be good to go. All right, so find each sum using summation notation. So we should have for A, the whole pattern is just every consecutive number up to 9 being squared. So I squared or K squared, doesn't matter. So my starting one is going to be 1 because it has to be 1 squared. And then my upper one, I end at 9, right? 9 squared. That's my answer. Over for B, when I gave you that n, you know you're going to start with n, and your pattern is going to be 1 over 2 to the k minus 1, or I minus 1. Now, again, I have to equal 1, so it's got to be 1 divided by 1, and the only way for 2 to a power to become 1 is if it's to the 0 power. So k minus 1 has to be 0, so k is 1. You could have also written it as your upper limit being n minus 1, and your pattern being 1 over 2 to the k. And then your starting then, in order to get 1, your k would just be 0. So there are a few ways you could go about this. It's really up to you. I will accept both. So we have now gone over finding our patterns using a general term where we just plug in n, our recursion formula where we use the previous term to find the next term. We've gone over factorials, those exclamation points, in order to help us figure out patterns. And we've used summation to both figure out all our numbers within the pattern and adding them up, as well as describing a pattern using summations. All right, so what I'm going to want you to do now is I want you to do the 10.1 homework. All right, please look for all due dates on Schoology and email me or screenshot any questions or concerns you may have. Okay, stay healthy, stay safe, and I hope to hear from you all soon.